Okay, so let's move to the next sample. The defective sample is called splay mark, and this is also something called by moisture. Now, if you look at the surface of this sample while I move the light source, you can see on the surface there is a kind of like uneven marks or patterns on the surface. Now this is because when moisture has nowhere to go, it migrates to the surface. Now, when it migrates to the surface and it traps there, followed by a rapid solidification process, it leaves a mark on the surface. So that's another thing caused by moisture. Now moving to the next one, this one is called flashing. Now if you look at this piece, what you should have is like a nice clean edge, very clear defined edge like that. However, over here, you can see it has a little piece of flange or like an overspill material outside the piece itself. Now this is largely due to there's a little gap between the mold pieces or tool pieces. Now one primary reason is maybe the pressure was not controlled well enough, so the mold was not sealed properly, or the mold itself can have some sort of damage that actually opens the gap, or when the mold was installed to the machine, it has a very small slight misalignment, and that gives you a little gap. Either way, that is the reason why the material comes out of a bit. Now, moving to the next one, discoloration. Now, if you look at this piece, on this end is nice, sort of clean, milky color, and over here you have this dark brown color. Now, that is a clear sign of polymer degradation. Now, in this case, it most likely due to the temperature setting was wrong. Either the polymer was badly degraded before it even gets into the mold, or in some cases, the polymer itself, you're using the wrong temperature setting. So anyway, this has something to do mainly with your temperature setting or the injection molding process. For example, either you have a high temperature that degrades the polymer, or the polymer has been sitting in a high temperature environment for too long. Both ways can cause significant degradation. Moving to the next sample, this one is called a burn mark. Now you can see this piece, it was injection molded, but part of it is okay, like this corner, or like this corner, or over here. These are all okay, but you can see clear damage or burn marks in certain areas. Now this is most likely due to poor temperature control with the mold or with the cooling. So this is kind of the other side of the same coin compared to the degradation. And the next one we're looking at is called jetting or sink marks. Now let me move the light a little bit. Yep. So now if I hold this sample, you can already see on the surface there's some kind of a bulging or uneven distribution. Now if I flip it a little bit, you can clearly see there are up and downs or some sort of contour on the surface. Now this is largely due to poor pressure control or flow control. So if you have the pressure was not continuous, it has a fluctuation, or when you inject the material inside the mold, the flow was somewhat obstructed or discontinued, then potentially you can have this kind of issue. Now these are all the defective samples and the general description of all of them. Finally, we're going to look at a few features that comes with the mold itself. Now the polymer has to go into the mold, so the first thing you look at is this little bit. It's like a little stick. Now this is where the polymer first gets in to the mold, and this piece is called a sprue. And by this piece, I mean this horizontal bit, sorry, vertical bit. This one is called a sprue. So the polymer from this end gets injected into the mold. And then, the sprue is S-P-R-U-E, sprue. This is just all the terms used commonly in injection molding industry. Then you're moving on. Once the polymer goes through the sprue, it splits ways. It goes like this and like that. Now these two L-shaped pieces, these are called the runner. And so it's basically a channel that guides the polymer towards where they're supposed to go. Now where they're supposed to go are the two pieces called cavity in this case. Now we have a rectangular cavity here, and we also have a dumbbell-shaped cavity here. Now of course, if you're molding different things, the cavity will have different shapes. Now one last feature I need to show you is something called a gate. Now I need to break the sample to show you, so give me a second. The pressure came out, that's fine. Now we can see with the sample, the gate is this tiny little bit I'm talking about, like a little lip. Now if I flip it, you can see the clear difference size between the gate and the piece over here. Now that gate, in this case, is a very thin, small horizontal slit. Now by pushing polymer with high pressure from one end into the gate and go into the cavity, when it passes through the gate, due to the volume, due to the cross-section shrink, there will be a significant pressure difference. And because that pressure difference, all the bubbles or moisture bubbles, they hopefully they will all stay on the other side of the gate and make the piece you're making here nice and clean and bubble free. So this is the common feature of any injection molded pieces. They may come with different designs or different sizes, but things like a sprue, like a runner, like a gate, cavity, these are all common things you can find with any injection molded pieces. So now this is the end of the injection molding demonstration. Thank you very much. And if you have any questions, feel free to send me emails. If you have time to come to visit me, my desk is in room 221 Harrison Building. So I'll be happy to answer all your questions. But for now, this is the end of the demonstration. Thank you very much.